Hi guys, big up to everyone for joining us. This is the Honesty Sciences and Mathematics TV channel, and today we are going to have an interesting topic on organic synthesis concerning the concept of epoxidation. And now basically we are mentioned as a range of a class of organic compounds, whereby we have mentioned the concept of this specific class of organic compound. I'm just going to use a functional group, so therefore trying to illustrate it as such. So I've given one of the examples of our organic compounds using this specific functional group, whereby I said this is a alpha radical, and then these are two oxygens, a carbonyl carbon joined to this oxygen, and then this H group at this specific point. And we had given a difference between this specific H group and then this particular part of this carboxylic acid. And the difference between this one and alcohol is that this one is joined to OH group, and then this is, of course, an RCOH given as such. So therefore, from this particular case, we're going to see that the concept of epoxidation involves the reaction between saturated compounds, that's alkenes, and what we refer to as peracids. And therefore, we're going to see, in part of our discussion, we're going to see the formation of peracids. Therefore, that is going to result in the formation of what we call epoxides. So in this particular case, we're going to look at a class of this particular kind of organic compounds, basically which is going to entail the aspect of one additional oxygen in this particular case, which we're going to illustrate using this particular example. So therefore, if you try to contrast this one with a carboxylic acid, then therefore we're going to see that for a peracid, it is going to contain an extra oxygen in this specific structure self-illustrated. So therefore this one we can just give it an example and say that this is a formula is given as such. Therefore this is going to represent what we refer to as a peracid. So if we try to look at this concept of epoxidation, then therefore I've said that we're going to consider the reaction between what we refer to as alkene and a peracid. And if we try to have a small recap of what I'm trying to mention, epoxidation is the process of formation of what we call an epoxide, which results from the reaction of the two reagents which I've said are alkene and a peracid. So therefore this particular product that we call an epoxide therefore is an ether. We had also talked about this particular class of organic compounds. This is an ether with an oxygen, going to use this symbol, with oxygen incorporated in you can say a three-member ring system. So therefore in this case we are going to expect a cyclic compound of this specific nature wherever we're talking about the concept of what we refer to as an epoxide. So therefore we're going to see different variations of this particular case, which is going to appear in form of a three-member ring that is incorporated in this particular three-member ring system that is containing oxygen. Earlier on, we had mentioned about a few classes of what we refer to as heterocyclic compounds. In that specific discussion, that was a video on the nomenclature of heterocyclic compounds. We had mentioned a few compounds which, of course, contain this particular oxygen that is found in our ring system. And we had mentioned one of the examples of this. This is it's not legible, just through an adjustment. So other ring systems that contain oxygen atom, for example, we had mentioned one of the examples like oxten, which we can be able to illustrate as such. So this is a oxygen that contain oxygen in a ring system, just similar to the epoxide that we are talking. We can also give another example like the tetrahydrofuran that we have mentioned in our previous video as one of the reagents that is being used in the formation of a specific product for alcohols and ethers respectively. So in this case, of course, we're going to see other ranges of these particular compounds. But of our interest today is the concept of epoxidation that is going to result in the formation of an epoxide that I've just mentioned as a three-membered ring with an oxygen incorporated in that specific structure. So therefore, if you try to look at these specific reactions, we're going to see that these are half esters of hydrogen peroxide, and therefore we can be able to have a general representation for this reaction between alkenes and the peracids as such. So therefore, we're going to have this as one of the examples of the one I've just illustrated given as such, and therefore this is going to lead to the formation of a peracid, as I've said. And of course we can be able to illustrate this one just using this, and therefore we are going to have that, and this is going to also lead to the formation of a carboxylic acids. And then later on we're going to see that this carboxylic acid basically is going to form what we refer to as a living group. We can be able to illustrate it as such. So to create the difference between this, of course we can just have this and this one R prime, so that we can be able to monitor the movement of different parts of the molecules in this specific case. So this is a general illustration for the process of epoxidation, whereby we're going to have an alkene reacting with a peracid, leading to the formation of an epoxide and a carboxylic acid given as such. So we're going to look at a reaction mechanism that basically is going to result in the formation of this specific epoxide, and this is going to be in a series of some short videos, since we need to of course elaborate on the formation of this specific group of organic compound that we refer to as a peracid. And therefore we're going to see as well as there are going to be different rearrangements, but generally we can be able to illustrate this reaction of this specific alkenes or a peracid, or the rearrangements which are going to be involved in this specific reaction. Therefore I can just be able to give a summary of this, but as I've said, we're going to elaborate on how these different reaction mechanisms are going to be of course experienced insofar as these peracids are concerned. So if I try to, so I'm going to give a rearrangement of this specific peracid. So this is going to be a O joined with that one at that specific point. And therefore in this specific reaction we're going to see that there's part of this molecule that is going to be joined with a nucleophile, and this basically is the OH group. Therefore we're going to have this one written as this one, and the nucleophile is going to attack this specific point, and therefore as we stated that this carboxylic acid is going to act as a living group, and therefore we're going to expect that the product side we're going to have a nucleophile that is going to contain the OH group that is going to be given as such, and then therefore we're going to have this carboxylic acid which we mentioned as a living group having that specific part. If you try to give this one as R prime, so given as such. So these are going to be the products of that general illustration for the reaction of a peracid trying to interact with this nucleophile in the formation of those two end products. So this one I've decided to make it in segments of short videos, which of course are going to assist us elaborate on the various points that I've mentioned. And therefore this one I'm just going to give you a reaction mechanism in another separate video, so that we can be able to see how this specific reaction mechanism or rearrangement take place insofar as epoxidation is concerned. So catch us in our next video as we look at the specifically the formation of this, what we refer to as a peracid, so that it can assist us understand how this general reaction takes place. So that is it for now. Bye. Catch us in our next video. God bless you.